Our framework for an open-ended system includes two components. A complex system, used as artifact generator to recursively grow and complexify artifacts over time, and a discovery algorithm, which leverages the concept of metadiversity search. Complex systems are great candidates for generating all sorts of constructible artifacts in Minecraft. But the design of artificial complex systems is often easier than navigating the space of structures that can emerge from them. Because complex systems are hard to explore, a major challenge is to automate the long-term discovery of novel and increasingly complex artifacts in those systems. Naive exploration strategies, as well as optimization-driven strategies, tend to converge towards subregions of the possible solution space, making them a poor fit to open-ended problems. Diversity-driven approaches seem to be a promising discovery tool for complex systems. Yet their standard definition assumes that the intuitive notion of diversity can be captured within a single representation space. This also limits the scopes of the final discoveries that might be highly diverse in that characterization space, but poorly with respect to other criteria. To address these challenges, we recently formulated the problem of metadiversity search, where an artificial discovery assistant incrementally learns a set of diverse representations to characterize behaviors in an outer loop, and searches to discover diverse patterns within each of them in an inner loop. A successful discovery assistant should continuously seek for novel sources of diversity, while being able to quickly specialize the search toward a new unknown type of diversity. To implement those ideas, we simulate an artificial chemistry system based on linear continuous cellular automaton for the artifact generator process, as well as an artificial discovery assistant called OLMS for the artifact discovery process. OLMS uses a goal-based, intrinsically motivated exploration as the diversity search strategy. At the same time, it incrementally learns a hierarchy of modular representation, which enables it to characterize divergent sources of diversity. Let's see how our discovery assistant is operating in Minecraft. Having access to a set of elemental chemical blocks, the discovery assistant prepares the initial mixture by combining the block in a delimited area of the petri dish. The discovery assistant also has access to parameters of the update rule, influencing the development of the final product. Having no idea of the range of patterns that can emerge from the system, the discovery assistant starts by randomly exploring the system. But this is very inefficient, as most of the patterns tend to vanish out. Far from being discouraged, the discovery assistant learns to characterize the discovered pattern in a latent BC space, which it can then leverage to target novel goals and to select parameters that are most likely to attain those goals. After some time, while having successfully discovered diverse patterns in its current BC space, Holmes' representational capacity saturates, making him blind to the new sources of diversity that are possible in the environment. Fortunately, the discovery assistant can instantiate new representation with their own neural capacity to further describe the newly discovered patterns. Holmes further decides how to cluster its discoveries into separate niches, allowing him to specialize and to explore divergent search spaces, while leveraging the accumulated knowledge from its diverse species spaces. Each time a node gets saturated, the split procedure is repeated, resulting in a progressively deeper hierarchy of modular representations. This figure shows the tree structure that has been actively constructed by the artificial discovery assistant during exploration. We show some examples of representative patterns of the type of diversity that is discovered in the respective nodes. We can qualitatively observe that the splitting procedure tends to separate the discovered pattern into what seems to be visually distinct niches, enabling the metadiversity search. Experiments have been conducted in 2D and 3D, allowing the discovery assistant to grow diverse buildings in Minecraft. The full database of discoveries can be visualized on the project website at the following link. Thank you for watching.